Good morning. Did
Morning.
you receive my email? I sent something back to you this morning.
You sent me an email this morning.
I replied back to what you said.
Oh, I didn't get to see the reply yet. All right. Is that something I should look at now?
You already unlocked it again for me, so
Yeah, I
it's
did.
just what you asked for.
Okay. All right. Okay. All right. All right, folks. So let's get started. Now, what I'm going to do today is actually let me open this screen up. Just give me a second here. And once again, let me just show you the screen. So to get to StatKey, which is what we're going to use for much of what we do for the rest of the course, you just type in the word StatKey just up here. And then you'll most likely, actually, I got star key there. Let me see. There we go. And this will be the first choice you'll get. All right. It'll say www.lock5stat.com. All right. So that's what we want. All right. And then you click that and you get to this screen. As I mentioned last time, if you want to watch an introductory video on StatKey, click this link up on the top and then scroll down the videos and then watch that introduction to StatKey. I mentioned that was required for you to do that, hopefully by before today. I know some of you didn't do it. It's always the case. With any course the teacher teaches, there's always going to be students who don't do it, but that's all right. You still need to do it. Listen, it's only 21 minutes. It'll take some time, 21 minutes of your time to watch this introductory talk. And also, I want you to watch this overview of Bootstrap confidence intervals, like 20 minutes, that one also. This third one on the top here, the overview of randomization tests, we'll look at that another time. But watch these two videos here. And what I'm going to do today is just demonstrate a couple main concepts about first of all, we're going to define what confidence intervals are. And I think we talked about that a little bit last time. And then I'll show you how to create them in StatKey. And then on quizzes and tests, you won't be needing to create them yourself, but you should be able to be able to answer questions about them, interpret them. All right. All right. So anyway, let me unshare this screen here.
So it's just the overview and the introduction. You gotta watch.
We're going to do more than that. Oh, you mean for the videos?
Yeah, just watch the overview and the introduction.
Well, let me show it to you again. Let me show it to you again. So, not the first one here. These two.
Mm-hmm.
The introduction.
Yeah.
Watch that first. Watch. I don't know why they have it in this order here, but watch the introduction to StatKey first, and then watch the overview about Bootstrap confidence intervals next. All right.
All right.
All right. But I'm going to actually demonstrate some of it today, but it'll be easier for you if you watch these two videos. All right. That's just my strong recommendation. I'm not obviously going to be watching what you do, but that's what I do recommend. Now, when you're in StatKey, as I showed you how to get to the screen here, to get back to StatKey, just click the StatKey link here, and it takes you back to the main screen, which is what we're going to work on today, a little bit later. But I have to give you some background before I work with this here, just so that you sort of understand what we're doing, all right? Because it's going to be hard to interpret things that you really don't have a clear comprehension of, all right? You have to be clear about what you're doing. Otherwise, this is not going to make much sense, any of this. So, actually, don't have you sharing the screen here, so that's not good. Or actually, I do have you sharing it. Yeah, all right. All right, so let's now go to a textbook. This book you don't have, because really your main textbook is almost useless for this, what we're doing here. And again, I'm a little unclear about the math department, why they chose this software and did not choose the textbook that goes along with it. Just my own. Once I went through the textbook, I thought it would be a perfect textbook to actually teach this course with, but they decided not to do it for whatever reasons. I'm going to share the textbook with you. This is the actual textbook for StatKey. These are the people who created StatKey, the 5 Lock, the Lock family, the 5 of them. They also wrote this textbook, which goes along with StatKey. So there's a chapter on confidence intervals. It's chapter 3. And I'm going to just review a few things from this chapter so that you sort of have an idea of what we're trying to do here. All right. I'm going to go to actually the first section where we talk about sampling distributions. All right. So we're going to talk a little bit about what that is, and then go right into confidence intervals, and then tell you why we're doing why we're using StatKey for these confidence intervals. So a sampling distribution is something that's created when we do many, many samples. Suppose we were interested in determining which of 2 political candidates that we're interested in voting for. There's 2 candidates, candidate A and candidate B. All right, we'll call one of them A, the other one B. Suppose we randomly select 100 people out of the voting population, and we ask them that question: which candidate do you prefer, A or B? And suppose that's the only 2 choices the person has, so they have to choose one of the 2. So they make their choice. And then what we do is we count them. Suppose we're interested in the number of people who like candidate A. We just count the number out of the 100, and the number of people who like candidate A. All right. So this diagram here shows us a little bit about what we're doing. We have our population, in this case, of voters. Okay, maybe in a particular city. So we have voters in a city. There's 2 people running for office. Let's say they're running for mayor of that city. And there's 2 candidates. So we ask those 100 people that randomly select, which candidate do you like? And suppose we're interested in counting for candidate A. So first of all, we have our population of voters. This is that big cloud here. And we do data collection. In this case, we randomly select 100 people out of, maybe there's 10 million people in our city. All right, it's a big city. There's 10 million people in the city, and we're choosing 100 of them, all right, to be in our sample. All right, so that's the data collection part of it. We create our sample. Now, in that sample, we're asking those 100 people that question: which candidate do you like, A or B? And then we collect the data, right? We're collecting that data. And then what we're going to do is do statistical inference in this case. Now, what is the inference that we're going to do? We're going to estimate the proportion of people in the whole population of voters who actually like candidate A versus candidate B. All right, but we're doing it from the sample. So the sample is going to be the way we estimate it. So that's why the arrow is pointing from the sample to the population, because we're going to take our information about the number of people who prefer candidate A, and we're going to say something about the number of people in the whole population who like candidate A. So we're going to calculate a proportion. Remember, a proportion is the number of people divided that like candidate A divided by the number of people in the sample. And that proportion is always going to be between 0 and 1 if we calculate it as a decimal. Does anybody have any questions about what I'm talking about? I really want to make sure that you understand what I'm saying. Is everybody really clear on this? I hope this simple example is good enough for all of you, all right? Because If you're stuck at this point here, you're not going to understand anything else. And I want to make sure that you understand what we're talking about here. Now, statistical inference is just a process of drawing conclusions about the entire population based on the information in a sample. Now, what kind of conclusions are we drawing? In this particular case, we're drawing what is a good estimate of the true population proportion of people who like candidate A. All right, we're estimating that. That's just one type of conclusion. We can draw other conclusions also. This is just one of them. All right. So now, one of the things that I want you to understand here, I'm going to make some additional points here, is that we have to understand the difference between what's called a parameter and a statistic. A parameter is a number that describes some aspect of the whole population. When I say to you, we want to estimate the proportion of people in the population who like candidate A, that proportion is called a parameter because it is a summary measure for the whole population. And how are we going to estimate it? We're going to use the sample proportion people in our sample who like candidate A. That proportion in the sample is called a statistic because it is a number that is computed from the data in a sample. So when I say the sample proportion, I'm referring to what's called a statistic. And when I'm talking about the population proportion, I'm referring to a parameter. Everybody understand the difference between those two words. One refers to the sample, the statistic. The other is referring to the population. Okay, any questions about that? Because that's important to understand that distinction. Okay. Now, typically the parameter is unknown, and we're using the statistic, in this case, to estimate the parameter. All right, the population proportion, unknown. We have 10 million people in our population. We're not going to ask all 10 million people, who do you prefer, candidate A or candidate B? No, it's impossible. We don't have the money, we don't have the resources, and many people are just not going to answer the phone or respond to a survey. You're just not going to do it. All right, so that's it. All right, now let's continue. There are certain symbols that we use to refer to parameters versus statistics. For example, the mean. We want to know something about the mean of a population. We use the Greek letter mu. It looks like a U, but it's called mu. We use X with a bar above it. We call it X bar as the sample mean. So different symbols are used for population parameters and sample statistics. Standard deviation, we use this letter sigma for the population standard deviation, and we use S for standard deviation for the sample. For proportion, this is what we're going to use. We're going to use P for the population proportion, and we're going to use P hat for the sample proportion, a little hat above it. Or it looks like an upside down V. And don't worry about correlation and slope here. We're not going to use these symbols at this point. We're only going to use these symbols that we're looking at. Now, when we do estimation, we're going to estimate two different types of parameters. We're going to estimate the mean, and we're going to estimate the proportion of the population. So the mean of a population, the proportion of population. The mean, it would be something that we're measuring, like height or weight. And proportion, again, we're just counting the number of people who answer a certain survey question a certain way and then divide by the number of people that we ask. That's the proportion. Okay, that's it. There's only two things you have to remember with this. Those two types of things, means and proportions. There's nothing else that we're going to be talking about. So we're trying to keep this as simple and as clear as possible to you so that you understand what we're trying to do. Now, here's an example of a proportion question, all right? Right here. It says the U.S. Census, this is a government agency, U.S. Census, states that 27.5% of U.S. adults who are at least 25 years old have a college bachelor's degree or higher. Suppose that in a random sample of n is equal to 200, remember small n represents the number of people in the sample. We call that sample size. All right, Suppose that in a random sample of 200 US residents who are 25 or older, 58 of them have a college bachelor's degree or higher. What is the population parameter? All right. Now, remember, we want to express proportions as decimals, all right, not as percentages. So I'm asking you now the question. You're going to give me the answer as a decimal. What is the population parameter in this case here? I want somebody to unmute themselves and give me the answer to that. It's right in the question here. There's only a little bit of a calculation you have to do, but I think you can do it in your head. Can somebody tell me what the population parameter is? It's given in the problem. Look at the problem. I think you could see it, right? Is it big enough? Can you see it? I mean, I think I can make it a little bit bigger. All right. So I made it bigger so you could see everything more. Just drag this down a little bit. Here we go. All right. Can somebody tell me what the population parameter is? This is very easy. It's in the problem. Don't go ahead.
Sorry, would it be 0.275?
That's it.
Oh.
That's it. Remember, to convert a percentage into a proportion, you divide by 100, right? Everybody clear on that? If you divide by 100, you move the decimal point to the left 2 spaces. 0.275 is the. All right, now here's a little more difficult, but it's not hard. What is the sample statistic? I want you to express it as a decimal, and you're going to need your calculator for this. Express it as a decimal. Your calculator will give you the answer as a decimal. What is the sample statistic? Remember, a sample statistic in this case is the sample proportion. Look at the sample data that's given here and give me the sample proportion. Maybe the person who answered before can do this.
I feel like this is wrong, but I somehow got 0.431.
And how did you get that?
I don't know. I just divided 25 by 58.
Why 25?
I don't know. I'm sorry.
What's 25 represent here, folks?
Oh, it represents the age. Okay.
Yeah, it has nothing to do with this proportion, right? It's just
Yeah.
we're describing the population. That's where the 25 years or older. It's the population of US adults who are 25 years or older. That's just a description. How many people are in the sample? Same person.
Would you do 58 divided by 200?
Yeah, that's it. All right.
Oh, okay. Yeah, I got that.
All right, so why don't you do that with your calculator and give me the answer for that?
It would be 0.29.
Yeah, 0.29, right? You take 58, which is the number of people who, now remember, this is a sample, right? And we're asking the people the question, do you have a college? What kind of degree do you have? That's probably what the question is, right? So they're going to say, some people are going to say they have a bachelor's degree, some people a master's degree, some people PhD, some people didn't complete college, right? Or didn't go to college. Well, out of the 258 of them completed at least a bachelor's degree or higher. So that's what we're interested in. 58 divided by 200 is 0.29. 0.29 is our sample proportion. That's the sample statistic. Is everybody clear on that? Because I've just got one person here who seems to be doing this. I'm not sure whether the rest of you are even interested in this, but I want to make sure that you know how to do this because this is going to be on your test. All right, I'm telling you, on your test. And I know you all want good grades. So that's why I'm taking my time with this so that you understand what we're doing. Now, I'm going to ask you another question regarding this here. So this was one survey or sample of 200 US residents. Let's say one of you did this through simple random sampling, all right? Suppose another one of you did this. Would you get the same answer? Suppose somebody else in the class did a simple random sample of 200 US residents. First of all, do you think you're going to get the same 200 US residents?
No.
No, of course not. So do you think you would get necessarily the same answer for the number of them who have at least a college bachelor's degree?
No.
No, of course not. So it's going to vary, right? Now, if we ran this sample many, many times, maybe all of you in the class would do this sample, we probably get all different answers, right? Everybody would get a different answer. Some of them will be larger than the true population proportion, which is 0.275. This one is bigger, 0.29. And some of you will get answers that are smaller than the population proportion. So there's going to be, this is called sampling variability. All right, sampling variability, which means from sample to sample, we're going to get different sample statistics, which will possibly or most likely be different than the true population parameter. All right, we're estimating the problem. Now, the fact that there is sampling variability means that we're not really sure which of the samples is a good estimate, because number one, we probably don't know in reality whether this is true or not. The U.S. Census states it, all right? Maybe they ask everybody in the United States who are 25 years or older this question, and every 10 years they might have asked them this question. But in between the 10 years that when they do these U.S. Census things, it may vary, it may change. So the point of the matter is we're doing these random samples. The answers are going to be different. That's called sampling variability. And therefore, the question is, can we rely on the sample statistic by itself to give us a good estimate of the population parameter, in this case, the population proportion? And the answer is, well, it's a reasonable, these are reasonable estimates, but wouldn't it be better to give a range of possible estimates instead of giving just one? Okay? And that's what confidence intervals do. They give you a range of possible values, all right, possible sample statistics that would estimate the population parameter, all right? And that's because of the sampling variability. So what we want to do is create an interval of values. Now the question is, how do we do that? Now, if you remember last time, we talked about, on Tuesday, we talked, I think it was in either chapters 20 or 21, we talked about creating a margin of error. I think we talked about that. Can somebody verify that that's what we talked about last time? Can anybody remember? We used the term margin of error. Anybody remember that? I think we did, right? Chapter 20. The beginning of the slides of chapter 20, we talked about a margin of error. So how do we create a margin of error? Well, it wasn't clear, except for the idea that we, first of all, have to calculate a standard deviation, right, for what's called the sampling distribution. We have to create a standard deviation for it. Now, for proportions, if you remember, it was the square root. It was the square root formula, right? It was something like the square root of P, which was the population proportion times 1 minus P divided by N, the sample size, right? If you remember that formula. And then we said something about multiplying it by 2, taking that standard deviation, multiplying by 2, and we get what's called the margin of error. And then what we do is we add and subtract that from our sample proportion. So in this case, the sample proportion is what? 0.29, right? It's 58 divided by 200. So we take the square root of 0.275 times 1 minus 0.275 and divided by 200. That's our sample size, and that would be our standard deviation. We multiply that, the square root of that by 2, and then we add and subtract that from 0.29. Now, that sounds complicated, a little complicated. It's not really that complicated, but in this course, we're not going to be doing that because in this course, we want to spend our time interpreting instead of calculating. But that's a traditional way of calculating the margin of error, and then taking the margin of error and adding it and subtracting it from the sample statistic, in this case, the sample proportion. And we get our confidence interval. And then we can say something like we're 95% confident that our sample statistic runs between, or we could say, well, actually, let's do that calculation here. And actually, I think it's a good idea to do that. So what I'm going to do, give me a second here to figure out how to do this. Okay. So I don't know if I could show you a calculator on here. But, we'll do this, I can display to you. I just want to show you the calculation itself without actually stressing the calculator. So let me think about this for a second. How to do this. So I'm going to stop sharing just for a second. Somebody sent me a chat message. Let me see. It's all right, that's fine. Just give me a second here, and I have to figure out how to open up my calculator. I'm going to stop the recording just for a second. Just pause it.